Okay, here we see our second example of interpreting the definite integral. In this example, we don't have a function p of t. We're just given some information about p of t. We need to think about, is p of t an amount function or a rate function? So as we read, suppose that p of t represents the population growth in Mexico in millions of people per year, where t is measured in years since 1900. So we have some clues here as to what type of function p of t is. We see the word population growth, the word growth there, in millions of, and then we see these units, people per year. Again, both of those giving us clue that p of t is a rate function. So we might want to make a note about that. P of t is a rate. And then we're asked to integrate from 0 to 10 p of t dt. We know from the second fundamental theorem of calculus that the integrating a rate of change gives me amount of change. So this is going to tell me the amount of change in the population of Mexico. So the total change in population in millions of people from time 0, so from 1990, to time 10, so 1990 plus 10 would be the year 2000. The units are millions. Let's talk about why that would be. We know that p of t is measured in millions of people per year. When we integrate, that's our rate function. When we integrate, we're actually multiplying values of our function, our rate function, by change in x. So that 0 to 10 is measured in years. And so the units there turn out to be millions. One final example of this type of problem. I'm going to let you read for a minute and set up what you think is correct. Okay, now let's talk through this one. We see that we have a rate function here, r. We see units here, liters per minute. So I have a rate function in r of t. I'm asked to find the amount of water that flows from the tank during the first 10 minutes. So I know that I need to integrate my rate of change function, 0 to 10, during the first 10 minutes. So that's from time 0 to time 10. Integrating r of t dt. I have r of t and y1 in my calculator. I'm using Math 9. When I integrate, I get 1800. The units there are liters, liters of water during the first 10 minutes. And then the last thing that we're going to talk about in this lesson is finding average values of a function. This is an application of the definite integral. Notice that what we're doing here is we're finding the average y value of a function. So graphically what we're thinking is that we have some function f. We talk about finding the average y value, then we're finding, kind of the y value that would be in the middle if we were to consider all of the y values in the function. This formula gives me the average y value because this integral gives me change in the original function, then divided by, so that gives me kind of overall change in capital F of t divided by change in x. And that gets me back to an average value of my integrated function there, function before it was integrated. Notice that this produces the average value of f of t. So whatever function you want the average value of, that's the function that you integrate. Let's look at an example of this. Here's an interpretive example. We see that C of t represents the cost in dollars per day, so that's a rate function, to heat my house. So if I integrate that rate of change function from 0 to 90 of the change in cost, so that in dollars per day, then I get the total amount of change. So total change or total amount of change to heat the house, total change in dollars. In dollars to heat the house from time 0 or day 0 to day 90. So in my explanation, I want to mention both what I'm finding, the total change in dollars, and then the time values over which I've found it. This formula, I see this 1 over 90 out here, and I see that that's 1 over b minus a. It's in that form. So that's telling me that I'm finding an average value. So this is the average, and it's the average of this function of c of t. So it's the average cost per day to heat the house over the 90-day period. So from t equals 0 to t equals 90. So notice what I've done with this formula is I've taken the total cost to heat the house, divided it by 90, and that gives me the average cost per day. We may also see average value questions presented to us just straight out, find the average value of, just a straight algebraic question. So if I see average value of f of t, not average rate of change, and we'll talk about the differences between those a little later on, but average value, average y value, then I know that I'm using the 1 over b minus a formula. That's the formula I want to pull out. So in this case, I would have 1 over pi over 2 minus 0. The integral from 0 to pi over 2 of cosine of 2t dt. Again, I'm going to do the integration on my calculator. What I find here is that the value of that integral is 0. If I look at a graph of it, I can see why. I actually did look at a graph of it, and so I see that the function is doing this, so I have the same amount of positive space as negative space. So I end up with an integral of 0 times 1 over pi over 2, and the average y value is 0. Again, looking at this graphically, the line y equals 0 would split the graph there just in half, so that seems like a reasonable answer. The remaining slides here take you through the development of the average value formula. You can read those. I'm not going to narrate those, but you can look through those so that you can see where that formula comes from and why it works if you'd like.